Hello students, in this video we are going to discuss an example from practical number 1. If G and H are isomorphic graphs, then show that degree sequence of vertices in G is same as degree sequence of vertices in H. We have given that G and H are isomorphic graphs and we want to prove degree sequence of G is same as degree sequence of H. So I am writing here, it is given that G and H are isomorphic graphs. So by definition of isomorphism, there exists a function from vertex set of G to vertex set of H. So therefore by definition of isomorphism, there exists a function, say f, from vertex set of G to vertex set of H such that f is 1 1, f is onto, and f preserves adjacency relationship. So in our classroom we have discussed what is isomorphism of graphs, and you know that F preserves, what is F preserves adjacency relationship? F preserves adjacency relationship means if there is an edge between any two vertices of G, then there will be an edge between corresponding vertices in H also. So I am writing here F preserves adjacency relationship means that is if UV belongs to edge set of G, then what is image of U, f of U, and what is image of V, f of V. This will be an edge in graph H. So we want to prove, to prove that degree sequence of G is same as degree sequence of H. Now instead of proving degree sequence of G and degree sequence of H are same, we are going to prove that if we are considering a vertex say U in graph G and its image V in graph H, degree of U in G is same as degree of V in H, then we can easily say that every vertex in graph G has the same degree as its image, degree of its image. So we are considering here a vertex U in graph G and we will prove that its image say V in H. Both these vertices U and V, that is V means phi of U, will have same degree. So to prove degree sequence of G is same as degree sequence of H, it is enough to prove degree of U is the same as degree of f of U in H. Degree of U in G. So we are going to prove degree of U in G is same as degree of f of U in H. So first is degree of U is equal to 0. We have considered U is a vertex in graph G and degree of U is equal to 0. Now our target is to prove that degree of f of U is equal to 0. So let f of U, I am considering f of U as, so let f of U is equal to V. Okay. So our target is to prove f of U, degree of V is equal to 0. Hope you are not confused between this UV and this UV. Here I have written arbitrary vertices, arbitrary edge E in U and V, vertices U and V. And here we have considered U as a vertex of graph G and f of U is equal to V as a vertex of graph H. Here I have written only meaning of F preserves adjacency relationship. You can change the letters of these vertices and edges, or UVH by, you can replace this as UV by XY and this as f of x, f of y if you are getting confused. Okay. So now again I am telling, I have considered U as a vertex of graph G and f of U is equal to V as a vertex of graph H. In first case we have considered degree of U is equal to 0 and we want to prove degree of V is equal to 0. Degree of U is equal to 0 in graph G means there is no vertex adjacent to U in graph G. Therefore, there is no vertex adjacent to U in G. So now I am considering a vertex. So if we consider X belongs to vertex set of G, then there is no edge between U and X. We have considered degree of U is equal to 0, that means no vertex is adjacent to U in graph G. So if we consider X, a vertex X in graph G, then that X will not be adjacent to U in graph G. That means there is no edge between U and X in graph G. If we consider X belongs to graph G, then there is no edge between U and X in graph G. Now there is an isomorphism from vertex set of G to vertex set of H. So for this U, there is a vertex f of U, that is V in graph G, and similarly for this X also there will be an vertex say f of X in graph G. So therefore in H there is no edge between f of U and f of X. This is because of isomorphism, and that is more specifically F preserves adjacency relationship means if there is an edge between U and X in graph G, then there will be an edge between f of U and f of X in graph G. And if there is no edge between U and X in graph G, then there will not be an edge between f of U and f of X in graph H. So by that third condition, there will not be an edge between f of U and f of X in graph H. And this will happen for every vertex X or f of X. This will happen for every vertex f of X in graph H. So that implies, and f of U, therefore degree of f of U is equal to 0 in H. And what is f of U? F of U is nothing but 0. Since f of U is nothing but V. F of U was V. So degree of V is equal to 0. So when degree of U is equal to 0, degree of V is equal to 0, we have proved this. Now we are considering degree of U not equal to 0. So case second, degree of U is equal to K and K greater than 0. And we have to prove degree of V is equal to K in H. This is our target, to prove degree of V is equal to K. Degree of U is equal to K in G means there are K vertices which are adjacent to U in graph G. Since degree of U is equal to K, that implies there exist K vertices which are adjacent to U in G. Say U1, U2 and so on UK. So these are vertices U1, U2 and so on UK which are adjacent to U in graph G. And degree of U is K, so I have considered these K vertices. Now by adjacency relationship, therefore by adjacency relationship the vertices. Now there is an edge between u2 u1 u2 u2 and so on u2 uk. That means sorry, since we have considered there is an edge between u2 u1 u2 u2 and so on u2 uk. So by adjacency relationship the vertices f of u1 f of u2 and so on f of uk are adjacent to f of u in graph H. And how many vertices are there? F of u1, f of u2 and f of uk. That means there are k vertices which are adjacent to f of u in H. That is, there are k vertices which are adjacent to f of u in H. So that implies what will be the degree of f of u? There are k vertices which are adjacent to f of u. That means degree of f of u is, therefore degree of f of u is k. And what is f of u? F of u is nothing but v. So that implies degree of v is equal to k in graph H. So we have considered when degree of u is equal to 0, we get degree of v is equal to 0, and when degree of u is non-zero real number say k, non-zero natural number say k, then we are getting degree of v is also equal to k in graph H. So we have proved that for every vertex u in graph G, if degree for every vertex u in graph G, its corresponding vertex f of u, that is v in graph G, both have same degree. So it will happen for all vertices in graph G, and hence we can conclude that degree sequence of graph G and graph H is same. Okay. So take a screenshot of this. In our next video we are going to solve another example. Thank you.